Today we'll learn about solids of revolution. Specifically, we'll look at revolving the curve y equals square root of x from x equals 0 to x equals 3 around the y-axis. Let's start by visualizing our curve. Here are our x and y-axes. And here's our curve, y equals square root of x. When we revolve this curve around the y-axis, each point on the curve will trace out a circular path. Let's look at a sample point on our curve. When we rotate this point around the y-axis, it forms a circle. The radius of this circle is the distance from our point to the y-axis, which is our x value. We can use the method of cylindrical shells to find the volume. Each vertical strip of our region, when rotated, forms a cylindrical shell. The volume of each shell is given by 2 pi r h dx, where r is the radius, our x value, h is the height, our y value, and dx is the thickness of the shell. Therefore, our total volume will be the integral from 0 to 3 of 2 pi x times square root of x dx. To solve this integral, let's substitute u equals square root of x. Then x equals u squared, dx equals 2u do, and our limits change to u equals 0 to u equals square root of 3. This gives us 4 pi times the integral of u cubed do from 0 to square root of 3. Solving this, we get our final answer. 4 pi times u to the 4th over 4, evaluated from 0 to square root of 3, which equals 3 pi square units. And there we have it. We've found the volume of our solid of revolution using the method of cylindrical shells.